Hey everyone, back with another Polars tutorial, and today I'll be talking about how to recode groups of variables simultaneously without the need for any kind of loops or anything like that. So typically, when you're, as just a primer, when you're working on any kind of programming task, if you find yourself doing the same task or activity just over and over and over again, in other words, if there's repetition, a good rule of thumb is to just kind of stop and assess what you're doing, because there's probably an easier way to do that. So here's like some sample data we're working with. And let's say these are all like yes, no items, and we wanted to do a recode on these four variables where we recode it so that 1 is equal to y and 2 is equal to no, or n. What we would be tempted to do is something like this. So just having a for loop in our replace where we say for I in every element of this list of variables in our data frame. And then call would be in this, the I would be in this PL call reference, and then we would do a dot replace where we recode so that 1 is equal to y and 2 is equal to no. There is an easier way to do that, believe it or not. One is just do it on all the columns at once. What's very convenient about polars is that the PL call method, or the polars.call method, can point to multiple columns at once. So we can just write all the columns we want in one PL call statement, and then this dot replace will operate on all these columns at the same time. So we can just go ahead and print that out and see the result of it. Get rid of this. Okay, so there we have it. So we were able to recode all these variables at the same time by just listing all of the columns that we want in the same PL call method, and doing a method that operates on all of them at the same time. Now, one thing you'll want to keep in mind when you do this is it's probably going to be a best practice to have all of these be of the same data type, and to have your, of course, you're going to want your data manipulation that you're doing to be applicable to all of the variables that you listed. And so the other tool that Polars offers is something I've talked about before in some of my previous videos. It's using nested data types. So namely, what I'll show here is how to do something similar, but using structs and lists. And so here's the input data I'll use for this example. So this is just some demographic data that I downloaded from the US Census Bureau. It's the number of births and deaths in every state in the United States. And what I'm going to do in this example is calculate natural change for each year. And so what natural change is it's just the number of births minus the number of deaths. So if the difference of that subtraction, if that difference turns out to be negative, then we say that natural change is negative, so it's putting downward pressure on the population. If it's positive, then it's putting upward pressure on the population. And so we're going to do that for every year using the 2021, 2022, all the way up to 2024. Now, typically what we'd be tempted to do, maybe not typically, I'm just kind of thinking of for myself and some of the previous programming languages I worked with, we'd be tempted to, again, kind of put in a loop, like for I in range 2021 to 2025, and just kind of pass those into our various column references to create, and also to create new columns. So nat change plus, or concatenate string I. So I would be this numeric year reference that we're passing into all these. So again, there's nothing wrong with doing this, but we could get the same results by working with structs and lists. And so let's take a look and explore how we can do that. And so the first thing I'm going to do here is just take our input data, and just zip them up into a struct. And so what this cs.starts with does is it looks for any variable that starts with births and any variable that starts with deaths. And so since our data is just very systematic in how it's named, there's no risk in doing this. And I'm just going to call these respective structs births and deaths. And so before we do anything, I always just like to take a look at my input data first. And so we will do that. Okay, here we go. Okay, so here's what our data looks like when it's all zipped up into structs. And again, if you don't know what a struct is just a collection of columns all in one place. So this birth struct contains all these columns in this one locale, and deaths contains all these columns in one locale. I don't know why I'm saying the word locale. It's not a location. Oh, I guess it is. A variable is a location in memory. So as you can see, this really simplifies our data, and it allows us to perform transformations on each of these values at the same time. So how would doing this look? So the first thing we'd want to do, so basically all we'd want to do is subtract bursts, and we subtract using .sub from deaths, and that's really all there is to it. But the only thing that is kind of a complicating factor is that even though we've created a new column that represents the subtraction of births and deaths, the keys in that column remain the same. And if you'll remember, there are invisible keys for each of these. So the key for this 5,184 value is going to be births 2021. So just because we've created a new column, we haven't renamed the keys or the fields. So the next thing we're going to do is we're going to rename the fields. And so the way we do that is you type in .struct because it's a struct method, and then rename fields. And what I did right here, this looks a little fancy, but all it is a list comprehension. It's just a shortcut for writing out a list of values. And so this is going to be natchange underscore 2021, natchange underscore 2022. If you don't know what a list comprehension is, definitely YouTube it. There's a lot of really great Python content on YouTube, and there's definitely some creators out there that can show you how to do a real easy list comprehension. For the purposes of this video, just know that this is how I'm renaming the fields so that we can unnest our columns. And so then after that, after we have our new struct called natural change, we can unnest these. And we unnest by just typing in .unnest and then natural change. And that should give us our new columns. So we'll take a look at these, see how they look. So there's our input data that we were working with, and here's the results. And so we can see that our natural change columns look about right. They are the difference between each of these respective elements. So negative 11,950 is the difference between 57,184 and 69,134. Same with natural change 2022. It's just this element minus this element. So as we see, structs give us a really good, really compact way of handling data transformations and recodes without the need for any kind of looping. And so we can do the exact same thing, the exact same recode with the second nested data type I'm going to be talking about, and that's lists. And so we're going to do the exact same transformation as before, but again, we're going to use lists instead. And so here what I'm doing is I'm doing the exact same code as before, a very similar code, except I'm using concat list. CS starts with births and deaths, and I'm calling these by the same name. So what this is going to be is instead of a struct of births and deaths, it's going to be a list of values. And again, the difference between a list and a struct is that a list is just a collection of values in a single column. It's not a collection of columns in a single column. And I don't know what I'm doing writing that in twice. Okay, so this is what our input data is going to look like. Should be very similar to what we saw before. And again, we can see that it's a list, and these brackets also indicate that we're working with a list now. We're not working with a struct. But I mean, what's so cool about polars is, as we're going to see down below, the data manipulation is exactly the same. And so basically all we do is we point to the births list, and we .sub that from the deaths list, and that'll do a transformation. And so before I get into this other transformation I do down there where I change it into a struct, we'll just take a look at the result and we'll talk about the challenge that we're faced with once we do this transformation. What the heck? Oh. So here's our natural change columns, or our natural change column with the same values that we saw up there. So we see that we got the same results as we did when we worked with the structs. Now the big challenge is how do we get these out? And there are a couple different ways we can do that. I think the easiest way is to just turn this list into a struct, rename the fields, and then just unnest the struct. And that'll just kind of do it all in one fell swoop. So to change a list into a struct, you just do .list and then toStruct, and then we have to name the fields. And so that's what this fields equals option does. And so again, I just kind of do what I did before. I pass in this list comprehension. So nat change string I being each of these year values that we're passing in. All right, and then we're just going to unnest that, and we're calling this struct natural change. Once we unnest it, it should just pivot those columns right out. And let's just go take a look. Hey, all right. So as we can see, there's a variety of ways that Polars offers to do operations on groups of variables all at the same time without any need for any kind of iterative looping. So that's all for this video, guys. If there's any questions you have about nested data types or performing operations on groups of variables simultaneously, feel free to ask about it in the columns and also in the comments, and also feel free to ask about any other Polars topics you'd like to see. So thanks again, and have a good rest of your evening.